We go in the coding part, let's explain first what is Quicksort. So, Quicksort is a fast divide and conquer sorting algorithm that works by repeatedly splitting an array into small parts and sorting them independently. It's popular because it's usually very fast in practice, easy to implement, and works well to large datasets. How Quicksort works. First, choose a pivot. Pick one element from the array, commonly the last, first, or a middle element. Next is partition the array. Rearrange the elements so that everything smaller than the pivot goes to the left, and everything greater than the pivot goes to the right. And next is recursively sort both sides. Apply the same process, pick a pivot, partition, then recurse to the left part and the right part. Then the last one is stop when partition are size 0 or 1. Now that we're done defining what is quicksort, let's go to first the computer will read the main method and then it declares 6, 7, 9, 4, 1, and 3 array, and then it will print out the original array, and this this code right here will start quicksort and the full array, and this is where all the recursive magic happens. Then system printouts sorted array, but before it it prints out the sorted array, this will go to the quicksort method. Now let's say we have we have this array of 6, 7, 9, 4, 1, and 3, and our pivot is equals 3, and our I is equals to negative 1. Then our 0 is equals to 0. The program checks if 6 is less than our pivot, which is 3, false. Then increment j will become 1. And then checks if 7 is less than 3, which is false. Then increment j again, j will become 2. 9 is less than 3, no. Then increment j again, j will become 3. And then 4 is less than our pivot, which is 3, false again. Then increment again, j will become 4, and 1 is less than 3, which is true. As we can say in the code, we increment I, and I will become 1, which is here. Now that our j is equals 4 and our I is equals to 0, the it will swap array in the index 0 and array in the index a number in the array index 4, which is it will become our array will become 1, 7, 9, 4, 6, and 3. After the loop ends, we swap our pivot with array I plus 1. I plus 1 is here, 7. And swap array 1 with array 5. So we will swap 3 and 7. So our array will become 1, 3, 9, 4, 6, and 7. Now that we have this set of array, we can now recursively sort the left and right of our pivot. So this is one array of 1, the then 9, 4, 6, and 7. The code will automatically ends because by the definition of quicksort algorithm, if only one that is remaining, the code will automatically terminate. So the what we will sort right now is this subarray. We pick the same process. We pick a pivot, which is the last, and everything is larger than the pivot, or everything larger than the pivot will be go from the right, and everything smallest from the pivot will go from the left. So this will become 4, 6, 7, and 9. And then we will quick sort 1 and 3. Now we have sorted our array.